Just like when solving equations, we had some equations that involved multiple steps. That may mean using inverse operations, the distributive property, combining like terms, or moving all the variables to one side. These same rules apply to solving inequalities. So in 9 plus 4t is greater than 21, there's going to be two steps. 4 and t are best friends, so we're going to wait to break them up till the end. So my first step is to subtract 9 from both sides of the inequality sign. Then I'm left with 4t is greater than 12, and my last step is to divide both sides by 4, because when I see the statement of 4t, that means that they're being multiplied, so the opposite of multiplying by 4 is dividing. And then I'm left with an inequality of t is greater than 3. In the next example, negative 6 and a are best friends, so I need to get rid of the minus 7 first by adding 7 to both sides. This leaves me with an inequality of negative 6a is less than or equal to 24. My last step is to divide both sides by a negative 6. Remember, when I am multiplying or dividing by a negative number on both sides of my inequality sign, I need to make sure that I flip that inequality sign. So my final answer is a is greater than or equal to negative 4, because I had to flip this inequality sign from here. In this example, you can see that we have a 5 and a negative x on the same side of the inequality sign. So just as we were able to combine like terms on the same side of the equal sign, we were to be able to do the same thing here. So 5x minus x, remember this is like saying minus 1x. Once I can combine those, I'm left with 4x. Then I'm still left with a positive 2, a greater than sign, and a 14. Then I just have two steps left to solve out for x using inverse operations of subtracting 2 from both sides. Then I'm left with 4x is greater than 12, and then my last step is to divide by 4 on both sides. So I'm left with x is greater than 3. Because remember, I read this statement here as 12 divided by 4. In this next example, we have to do the distributive property first, because I see a number outside of a parentheses. Remember, I only distribute the 3 to everything that's inside the parentheses, so it only gets distributed to the x and the positive 1. Everything else is just going to come right along, so I'm left with 3x plus 3 minus 4x is greater than or equal to negative 5. Then once again, I have some like terms that I can combine. So 3x and a negative 4x results in a negative 1x, and I still have a positive 3, a greater than or equal to sign, and a negative 5. Then by using inverse operations, I subtract 3 from both sides, and I'm left with negative 1x is greater than or equal to negative 8. And lastly, I divide both sides by a negative 1. Remember, I see that I'm dividing by a negative on both sides of my inequality sign, so I flip my sign, so x is less than or equal to positive 8. This next example, I also have to do the distributive property first. Remember, I'm distributing a negative 2 because the sign that's in front of a number or variable goes with it. Everything else stays exactly the same. So I still have a 15, a less than, and a 5. And then after doing the distributive property, I am left with negative 8m minus 14. I can combine my positive 5 and negative 14 because they're both numbers and they're on the same side of the inequality sign. That leaves me with negative 9 and then also still that negative 8m. Using inverse operations to get m by itself, I add 9 to both sides. I'm then left with 24 is less than negative 8m. And then I divide both sides by a negative 8. Same thing here. I'm dividing both sides of my inequality by a negative number, so I'm going to flip my sign. I'm left with negative 3 is greater than m. Remember, this is the same thing as m is less than negative 3. Notice in both of those inequalities, the smaller portion of my inequality sign is pointing towards the m. So it's saying that m is the smaller part. So both of those inequalities mean the same thing. In this next example, you see variables on both sides of the inequality sign. Remember, if I ever want to combine things that are on opposite sides, I use opposite operations. So I'm going to subtract 3n from both sides of my inequality. This leaves me with 3n minus 1 is greater than 8. And then using inverse operations, I'm going to add 1 to both sides. And I am left with 3n is greater than 9. And then I'm going to divide both sides by 3 to leave me with a solution of n is greater than 3. In this example, we will do the distributive property first. This leaves us with 10 minus 8a is greater than or equal to 10 minus 8a. I have a's on both sides of the inequality sign, so I'm going to move them to the same side by adding 8a to both sides. In this example, you notice that my 8a's cancel out on both sides, and I'm left with 10 is greater than or equal to 10. This is a true statement. 10 is bigger than or equal to 10. Since my variables disappear and I'm left with a true statement, just like in solving equations, this would leave me with infinite solutions. So that means that there's any number I can plug in for a at the very beginning of this inequality, and I will be left with a true inequality statement. In the next example, I'm going to combine my like terms of 7m and negative m. Remember, that's like a negative 1m. So once I combine those, that leaves me with 6m plus 7. I have m's on opposite sides, so I'm going to use opposite operations to combine them. Here, once again, my variables disappear on both sides of the inequality sign. This time I'm left with negative 5 is greater than positive 7. This is not a true statement. Negative 5 is not greater than 7. Since my variables disappeared and I was left with a not true statement, my answer is no solution. There's no number that I can plug in for m in this very original inequality to get a true inequality statement.